Good day, students. My name is Iwalewa Matthew. I'm here to take you mathematics, and our topic today is trigonometric 1. Under it, we shall be looking at basic trigonometric ratios, which are sine, cosine, and tangent with respect to right angle triangle. And we shall be looking at trigonometric ratios of angle 30 degree, 45, and 60 degrees. Let's start with basic trigonometric ratios, which are sine, cosine, and tangent. These three trig ratios can only work if you have a right-angled triangle. So it works with a right-angled triangle. Are we together? So what is a right-angled triangle? A right-angled triangle is a triangle in which it has one of its angles to be 90 degrees. So when a triangle that has one angle that is 90 degrees, such triangle is said to be a right-angled triangle. Thus, the remaining two angles add up to 90 degrees since every triangle contains two right angles. So the sum of the two opposite angles of a right-angle triangle will also give us 90 degrees. So if one of the angles is already 90, then the other two angles, when you add their sum together, it will also give you a sum of 90 degrees. For example, if you have 40 and 50 degrees, then the third angle is 90, then that is a right-angled triangle. Now let's continue. Now looking at this right-angle triangle ABC. In triangle ABC, you look at B plus C is equal to 90 degrees. That is, when you add this angle together with this angle, you can see that is the two opposite angles. Since angle A is already 90, then when you add angle B and C together, that will give you a sum of 90 degrees. So this type of angle is said to be a complementary angle. That is, the sum of two angles added to give you 90 degrees. Any angle that you add together to give you 90 degrees are said to be complementary angles. Now we now use capital letters to represent the angle, and we use small letters to represent the side facing the angle. And when you look at the diagram above very well, you notice that angle small letter A, that the small letter A is facing the right angle, which is capital letter A. And when you look at angle B, is also facing small letter B, and angle C is also facing small letter C. So we can say that small letter A is the opposite side to the right angle. And this angle A is called the hypotenuse because it's the side facing the right angled triangle. So any side that is facing the right angled triangle is referred to as the hypotenuse. And every right angled triangle obeys the law of Pythagoras, the Pythagoras rule. Don't forget, the Pythagoras rule states that the hypotenuse square is equals to the sum of the square of the two opposite sides. So in the above triangle, in this triangle, so the hypotenuse square, which is a square, will be equals to b square plus c square. Now, so when you look at that is the side facing the right angle triangle A, which is a square equals to b square plus c square. Now let's now move to the basic trigonometric ratio, which I've told you that we have three. Then here I'm adding three more to these basic trig ratios. The remaining three that was added, they are the inverse, or let me say they are reciprocals of the main three trigonometric ratios. So the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. The reciprocal of tangent is cotangent. You can see is the one I am underlining on this page. So cosecant is the reciprocal of sine, secant, that is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So the first three are commonly used, but the remaining three are the reciprocal of the first three. And their short forms are sine, which is sin, is not pronounced as sin. is not pronounced as sin. It is pronounced as sine, S-I-N. Though the real spelling of sine is S-I-N-E, but it is being shortened as S-I-N. And cosine is being shortened as cos, C-O-S. And tangent is being shortened as tan. And cosecant is being shortened as cosec. And secant is being shortened as sec. And cotangent is being shortened as cot, respectively. Now, let's now take the trig ratios one after the other, where we have sine B. And when we are talking of sine B, that will be the side facing B, that is small letter b, all over the side facing the right angled triangle, which is B all over A. And if you are also taking this C as well, that will be the side facing C, which is small letter c, over the side facing the hypotenuse side, which is A. So in short, we can say that sine is equal to opposite all over hypotenuse. And moving to cos now. If you look at the same right angle triangle, I told you that all these trig ratios this with a right angled triangle. So now when you look at the diagram under this, we have cos B. If you are taking B, that will be the side adjacent to B. Though normally the side opposite to B is small letter b, but the side adjacent to B will be C. So that will be C over the hypotenuse side, which is A, and the adjacent side to C will be B, which is B all over A. So in short, we can also say that sine and cos is also adjacent all over hypotenuse. Now, going to the tangent. So we also have the side opposite, which is B. So when you look at B, that is opposite of B, which is small letter b, all over the adjacent side, which is C. And when you also consider the angle C, that is the opposite of C, which is small letter c, over the adjacent, which is B. So in short, we can say that tan is equals to opposite all over adjacent. You can easily remember this formula. So I used a short acronyms that will make you to understand the formula for each of these trigonometric ratios, which is pronounced as SOHCAHTOA. Then the SO means sine is equal to opposite all over hypotenuse. The CA means cos is equal to adjacent all over hypotenuse. And the TOA means tan is equal to opposite all over adjacent. Now let's take the trig ratios one after the other in doing some examples. Don't forget, I told you that the sine is the same thing as opposite all over hypotenuse, and the reciprocal is cosecant, which is pronounced as cosec. Now example 1. Find sine theta in the above figure. When you look at sine theta, it means I'm looking for the side facing the angle, which is angle theta. So the angle is theta, but I'm looking for the side facing the angle. But if I want to look for this side, it means I will use a Pythagoras rule, because when you are dealing with side, you use Pythagoras rule. But when you are dealing with angles, you deal with trig ratios. So here I will use Pythagoras rule. And since the third side is labeled x, and don't forget, if I want to look at this now, I can know the hypotenuse and the opposite side. The 17 is the hypotenuse side because that's the side facing the right angle. And x is the side facing the theta, which is the opposite. So 15 is the adjacent side, which is the third side. So if I want to solve this question now, it's very simple since I have identified what I'm going to use, which are the hypotenuse, the opposite, and the adjacent. So my formula will be x squared plus 15 square, which is the opposite square, plus the adjacent square, plus the hypotenuse square is equals to, plus the adjacent square equals to hypotenuse square, which is x squared plus 225. That is 15 square means 15 times 15, which will give you 225, which equals to 17 square, 17 times 17, which will give you 289. So that will give you x squared is equals to, you can say I'm bringing equals to 289 because that's the first number after equal sign. Then I'm bringing the 225 from the left hand side to the right hand side. So when you are bringing a number from the left hand side that is crossing an equal sign, the sign will change to the opposite sign, and the opposite sign of plus is minus. So plus 225 will change to minus 225 when it gets to the other side. And when you subtract 225 from 289, that will give you 64. So that will give you x squared is equal to 64. Taking the square root of both sides, if you want to remove square root, if you want to remove square, you use square root. And if you want to remove square root, you also use square. So that will give you the square root of x squared is equal to square root of 64. And the square root of x squared is x, and the square root of 64 is 8. So since I've gotten the opposite side, then I can now go back to the diagram and put the value of x there. So with that, now I can look for the value of my sine theta, which is opposite all over hypotenuse. And I've gotten my opposite to be 8. My hypotenuse is already given to me, which is 17. So my answer here is sine theta is equal to 8 all over 17. Example 2. Find x in the diagram below. Now when you look at the example 2, we are given the angle. We are given the angle, but we are asked to look for the side. In the first question, we are not given the angle. We are not also given the opposite side. So here, I will use the formula directly, which is opposite all over hypotenuse. I already know my opposite to be x, which is the side facing the given angle. And this, when you look at this very well now, this is the right angle, which forms a perpendicular line. Perpendicular line. So the side facing the hypotenuse is 10. So it means my hypotenuse is 10 and my opposite is x. So here I have, since the opposite of the given angle is known, the hypotenuse of the triangle and the hypotenuse of the triangle. So one can use sine. Why? Because what I'm looking for is the opposite and I'm given the hypotenuse. Now go and check your Shokatua. Which of these has opposite and hypotenuse? So when you look at it very well, you notice that is the what? Is the sine. And that's why we are taking sine 22 degrees, which is the given angle, is equal to opposite, which is x, over the hypotenuse, which is 10. So cross multiply from here, from this. When you cross multiply from there, you have x times 1, which is x, because this is all over 1. So x times 1 will give me x is equal to 10 times sine 22 degree. And sine 22 degree will give us 0.3746. Taking your 4 figure table, go to the signs of angle in degrees. So when you get there, check sine 22 under 0, which will give you 0.3746. Then multiply it by 10 meter. So that will give you 3.746 meter. So the value of x there is 3.746. You can also approximate your answer to be 4 meter, because the hypotenuse is also given nearest to the whole number. So I can also approximate my answer here to be equals to 4 meter. Now let's go to the second one, which is the cosine. The trig ratio cosine is adjacent divided by hypotenuse, and its reciprocal is secant. So you can see. Now, there is something I want to explain to you under this cosine and sine. When we are talking about cosine and sine, the two are said to be complementary. Why? Because sine 20 degree will also be equals to cos 80 degrees. Sine 20 degrees will also be equals to what? To cos 70 degrees. Why? Because the two of them are said to be complementary. So when you go to your 4-figure table and check the value of sine 20, and you also go and check cos 70, you will notice that they will give you the same value. And that's exactly what I explained on this page, which is sine B will give you B over A, which is equal to cos C. And sine C will also give you C over A, which is equal to cos B, because they are what? They are complementary angles. So for complementary angles, the sine of one is the cosine of the other. That is, if I have sine of a angle that will give me the cos of 90 degrees minus that angle. So it means if I have sine 10 degrees, that will be sine 10 degrees is equals to cos 90 degrees minus 10 degrees. So sine 10 with degrees will give me cos 80 degrees. And when you look at it very well, when you add them together, you have 90 degrees. So sine and cos are complementary angle. So the sine 30 degrees will also be equals to cos 60 degrees. So once you can add the two angles together to give you 90 degrees, they are said to be complementary angle. For example now, so sine 2x is equals to cos 3x. We want to check if sine 2x will be equals to cos 3x. Now, looking at the solution, we have sine is equals to cos 90 degrees minus what? Minus theta. Now, we have sine 2x. So sine 2x will give me cos 90 degrees minus theta, which is equation 1. Don't forget, that will be the formula. So, but we are given that sine 2x is equals to cos 3x. So, from here, combine the equation 1 and 2 together, where we have equation 1 to be sine 2x to be equals to cos 90 degrees minus theta. I told you if you want to get the complementary angle of the other angle, you subtract the angle from 90 degrees. It will give you the complementary of the other angle. So here I can say that 90 degrees is equals to 90 degrees minus 2x is equals to 3x. Sorry, this is not 900. It is 90 degrees. That is a typographical error. So this should be 90 degrees minus 2x is equals to 3x. So 90 degrees is equals to, when you collect the like terms, that will be 3x is equals to 3x. Now I have 2x. Take 2x. Take 2x. So this should be 90 degree is equals to 3x. Sorry, is equals to 90 degrees. 90 degree is equals to 3x. Now, this is minus 2x. Take it to the other side. That will be plus 2x. So from here, it means I will have 90 degree is equals to 5x. Will give me 5x. So you can see that is 90 degrees equals to 5x. So now, 90, if I want to get x, so if I have 90, that will be divide both sides by 5, which will give you 90 over 5, which will give you 18 degrees. Now, go there and put the value of 18 to be x. So that will be 2 times 18. And check, 3 times 18. You will notice that they will give you the same values. They will give you the same value. Now, so you can check that one. You can use your calculator to check the value of what I've said there, which is 2 times 18, which will give you 36, and 3 times 18, which will give you 54. So when you add it together, 54 plus 36, you will see that it will give you a sum of 90 degrees. So you can see that they are what? They are said to be complementary. Example 2. The angle of elevation of the top of a tree is 60 degrees. You can see that is the angle, which is 60 degrees. If the point of observation is 4 meters, which is the ground level, from the foot of the tree, how far is the point from the top of the tree? So the top of the tree is represented by what? By x. So it means that this is representing the tree, and this is the base, the floor of the tree to where the angle is being chosen. Now, looking at this, so I'm looking for the value of x, which is the side facing angle 60 degree. Now, looking at this now, if 60 is my opposite, 60 is my angle, then the side facing 60 degree will be my opposite, where this is the hypotenuse. Then it means I'm having only opposite and adjacent. Now go and check your trig ratio, which one speak about opposite and adjacent, and you see that that is what? That is car, which is cos is equals to adjacent that will be, yes, cos is adjacent over hypotenuse. Adjacent over hypotenuse. So from here, we have, let the point of observation from the top of the tree be x, which is the hypotenuse. So it means the x is represented by the hypotenuse, which is adjacent. That will be the adjacent side, where the top of the tree be x meters. So we have cos 60 degrees, which is cos is adjacent, which is cos, that is 4, the adjacent side, over x, that is adjacent over hypotenuse. So x is the hypotenuse. Now here we have cos 60 is 0.5. When you check your 4-figure table, cos 60 will give you 0.5, which is equal to 4 over x. And when you cross multiply from here, that will give you x times 0.5, which will give you 0.5x is equal to 4. Then divide by both sides by 0.5. So that will give you 4 over 0.5, which will give you 8 meters. So it means how far is the point from the top? The length will be 8 meters. Now this is another example, which is example 3. Given that cos theta equals to 0.7431, where x is greater than theta, x is greater than 0, and x is greater than 0, but x is less than 90 degrees. Use tables to find the values of 2 sine x. It means here we are going to make use of our 4-figure table. Here we have cos x to be 0.7431. So here we go to the 4-figure table. We check under the cos of angles. You check the numbers. Under where can you see 0.7431? So when you go to under the cos 42 degrees, under 0, 42 under 0, you will see that you have 0.7431. And if you want to use a calculator, just press shift cos. So shift cos will give you, then press shift cos 0.7431. You will see that you have 42 degrees. Approximate your value to the nearest degrees. So when you do it, you will notice that will give you the correct answer. Now, the second one is tan x all over 2. Tan x all over 2. Tan x over 2. Now, if I want to look for, tan 42 over 2. And tan 42 over 2, divide 42 divided by 2, that will give you 21 degrees. So check tan 21 degrees under your 4-figure table. So when you check your tan 21 degrees, check tan 21 degrees. So that will give you 0.3839. So that is for the third example. Now let's now go to tangent of an angle. So don't forget the formula is opposite all over adjacent. So let's look at example. Find y in the figure below. If I want to look for y, check the side you are being given. You have the opposite and the adjacent. So you have adjacent and you are looking for the opposite. So that will be tan 32 degrees equals to opposite y over adjacent, which is 6. So cross multiply from here. That will also give you y is equals to 6 tan 32 degrees. So my y is equals to 6 times 32 degrees will give you 0.6249, which will give you 3.75, which is approximately 4 meters. Now, example 2. Find x in the figure below. If I want to look for the x, I will still follow the procedure I used in example 1, which is tan 35 degrees. How will I know that I'm going to use tan? Just look at the side you are being given from the diagram. When you look at this very well, I'm given angle 35 degrees, the opposite of it, and the adjacent side of it, which is 2, opposite and adjacent. So that is why I'm using tan 35 degrees, which is opposite x over x plus 15 degree. And here, from here, cross multiply from here. When you cross multiply, so that will give you x is equals to, look for the value of tan 35 degree. The value of tan 35 degree is 0.7002 is equals to x over x plus 15. Then from here you can now cross multiply. So when you cross multiply from here, so that will give you x is equals to 0.7002 multiplied by x plus 15. Now open the brackets one after the other. That is x is equals to 0.7002 times x, which will give you 0.702x plus 0.7002 times 15. So it means you use 0.7002 to open the bracket. So, and don't forget the x there is the same thing as 1x. So, and that's why I'm applying 1 to that x, because any variable that is standing is still the same thing as 1. So if I have 1x is equals to 0.700x plus, when you multiply that one by 15, you have 10.503. So now collect the like terms. So I have 1x is equal 1x. Take the term that is having x on the right hand side, which is on this side. Take it to the left hand side. So it has positive, then the sign will change to minus. So that is minus 0.7002x, which is equals to 10.503. So from here I have, when you subtract it, you have 0.2998x is equals to 10.503. Then divide both sides by the coefficient of x, which is what? Which is 0.2998, and that will give you 35.03. Now, the example 3. If sine x equals to 3 over 5 and x is an acute angle, find cos x plus tan x. In this kind of question, you are going to look for the third side before you can get the value of cos x and tan x. So here, looking at the diagram, if I'm given sine x, it means that sine is opposite, opposite over hypotenuse. That is opposite over hypotenuse. And the first thing for me I'm going to do here is to first draw the right angled triangle. Then I will now label it. So when I label this to be x, then the side opposite is 3. That is opposite hypotenuse is 5. So then to get the third side, I have to look for the adjacent, which is by using Pythagoras rule, which is hypotenuse square is equal to the square of the sum of the two opposite sides. That is 3 square. So I represented the unknown side, which is the adjacent side, as a. So which is a square plus 3 square is equal to 5 square. So a square equals to 25 square, which is 25, minus 3 square, which is 9. So I have a square is equal to 25 minus 9, which is 16. So hence, the square root of a is a, and the square root of 16 is 4. So for me to look for the value of my cos x, so cos is that should be car, which is adjacent over hypotenuse. So it means my cos will be adjacent, which is 4, over hypotenuse, which is over 5. Then plus my tan, that is 12, opposite over adjacent. My opposite here is 3, that is 3 over adjacent, that is 3 over 4. So that when you look at the next step, you see that I have, so cos x plus tan x equals to 4 over 5 plus 3 over 4. And when you look for the LCM of the two, that is 20. Then 5 in 24, 4 times 4, 16, plus 4 in 20, that is 5. 5 times 3, 15. 16 plus 15 will give you 31. Sorry, that is an error. 31 over 20. So how many 20 will you see in 31? That is 1. Then remainder 11 all over 20. So that is the value of cos x plus tan x. Now, Let's now go to the last part of the trig 1, which is the how you can get the value of the trig ratios. So we are starting with angles 30 and 60 degrees, and to consider the trigonometric ratios for the special angles 30 degree and 60 degree, we shall consider an equilateral triangle of side 2 units. So we are going to look at an equilateral triangle. Don't forget all the sides of an equilateral triangle are equal. Now, is that from this, the total length of this shape is 2. But because I've divided the shape into 2. So it means one part will be 1, one part will be 1. But don't forget, this side will still be 2 since I'm not dividing this. This side will also be 2 units since I'm not dividing. But when I bisect this into 2, it means I've divided into 2 equal parts. Where the first triangle will give me 1, the second will also give me 1. Are we clear with that? Then, if the triangle is bisected, I have explained that. So it means I will have one part to be 1, 2. Then it means this side is unknown. This side will be unknown. So I am representing this side to be H. To be H. To be H. Now, if I want to look for the value of this H now, it means that will be if the value of the altitude, which is the side H, is H, can be obtained using Pythagoras theorem or Pythagoras rule. Don't forget, this is also a right-angled triangle in which I have the hypotenuse to be 2 and my one of the two opposite sides to be 1. So if I want to look for the second opposite side, that will be 1 square plus h square is equals to 2 square, which is h square is equals to h square is equals to 4, which is 2 square minus 1 square. Don't forget, I can still do it as this. H square is equals to 1 square, that is 1, if I can, let me use a simpler method that you can understand. If I have h square from this step, h square plus 1 square will give me 1, which is equals to 2 square, which will give me 4. Then from here you can collect the like terms, which will give me h square is equals to 4. Bring this plus 1, this plus 1. Bring it to the other side, that will give you minus 1, which is what you have there. So which is equals to, I can say my h square is equals to 3. Sorry. So if I want to look for the value of my h will now be the square root of 3, which does not have a real value. So this is an irrational value. So my h is something as square root of 3. You can see. So my h is something as square root of 3. Square root of 3. So it means I have this side to be square root of 3. Then if I now want to look for sine 30 degrees now, sine 30, it means I will look for this. I'm losing this angle. It means I will ignore this angle 60 degree. Now taking angle 30 degree now. So if I want to start with sine 30 degree, this will be my opposite all over hypotenuse. It means sine 30 will be 1 over 2. Then cos 30 will also be, that will be adjacent. Don't forget, I know this side to be root 3. So if I want to use cos 30 degree, that will be adjacent over hypotenuse. That is adjacent, which is opposite is 1. Then adjacent will be root 3 all over 2. So it means my cos 30 degrees will be what? Will be adjacent over hypotenuse, which is root 3 over 2. Now, if I want to look for my tan 30 degree, which is opposite over adjacent, that will be opposite will be 1 all over adjacent, which is root 3. Then if I want to look for my sine, now I'm now taking 60 now. That is for, the first one is for 30, then the second one now is for 60. If I'm taking angle 60, now this will be my opposite, which is root 3. Then this will be my adjacent, which is 1, and this will still be my hypotenuse. So if I want to take sine 60 now, that will be opposite, which is root 3, over adjacent, which is root 3 over 1, which is still the same thing as root 3. Now, if I want to now look for, sin 60, that is root 3 over 2 opposite over hypotenuse, which is root 3 over hypotenuse, which is 2. And if I want to look for cos 60, that will be adjacent, which is 1 over 2, which is adjacent over hypotenuse, which is 1 over 2. And if I want to look for tan 60, that is opposite, my opposite, that is 1, root 3 over adjacent, which is root 3 over 1, which is the same thing as root 3. So I will still give you a table that shows all these values, which you can sit down and also know on your own. Then look at the first example here now. Look at the figure with respect to the given 60 degrees. It means we are given an angle of 60 degrees. So you use this angle to look for the value of x and y. So the known side is the adjacent, which is 4. So now this will be my opposite, this will be my hypotenuse, and this will be my adjacent. So it means I'm given the adjacent side to be 4. The unknown side is x, which is the hypotenuse, and y, which is the opposite. Sorry. So if I want to look for the value of my x and y, now I will first look at what am I given. I'm given the adjacent side. Now go and check your trig, the formula, which is SOHCAHTOA. Which of these has to do with adjacent? So I have cos, that is adjacent over hypotenuse, which is adjacent is 4 and my hypotenuse is x. So here I have 4 over x. And cos 60 degree, according to what we have done here, when you check it, cos 60 degree is 1 over 2, which is 1 over 2. Cos 60 is 1 over 2. So cos 60 is 1 over 2 is equal to 4 over x. So when you cross multiply here, that will be x times 1, which is x, is equal to 2 times 4, which is 8. So it means my x will be 8. So it means without getting your hypotenuse, you cannot look for your opposite. Because if I want to use opposite, that is opposite all over hypotenuse. So it means anything that has to do with hypotenuse, that has to do with that opposite here, I have to know the hypotenuse. And that is the reason why I'm looking for the hypotenuse first before the opposite side. Now let us go and look for the opposite side, which is y. Now to find the value of y is the opposite side and 4 is the adjacent. So I can also use tan 60, or I can also use sine, which is opposite over hypotenuse. And here I can also use tan y, which is tan 60 degrees is equals to y over 4. Don't forget tan 60, that is opposite over adjacent. That is opposite, which is y, over adjacent, which is 4. So, and don't forget that tan 60 degrees is the same thing as root 3. So tan 60 is root 3 is equals to y over 4. Also cross multiply from this step. So that will be y times 1, that is y, is equals to 4 times root 3, which is 4 root 3. So it means the value of my y will be 4 root 3. Now let's go to the trigonometric ratios of angle 45 degrees. Angle 45 degrees. So that is for trig ratios of 30 and 60 degrees. We did that together because they are complementary angle. When you add 60 and 30 together, you will see that they are complementary angle. Also, when you check it very well, you notice that sine 30 degree there will be equal to cos 60 degrees. So why? Because they are said to be complementary angles. Now let's now consider, don't forget, when we want to look at the complementary angles of sine and cos, we'll use an equilateral triangle. But here we are still going to use the same triangle, where we are going to use an isosceles triangle of square units, 1 unit of a square. Consider a square 1 unit. That is, it has a side of 1 unit. Now, suppose the length of its diagonal is x. you can see the diagonal line that comes from one angle to the base angle, that is the opposite side of the angle. Now we have we have this angle to be 90 degrees. Well, look at it very well. This is a right angle. This is also a right angle. This is a right angle. This is also a right angle. But when we bisected the line is giving us a what? It's giving us 45 degrees. Why? Because the line is 90 degrees before, but when we bisected the line into two, that is 90 divided by 2, which will give us 45 degrees. You can see that it's quite different from the previous one. So suppose the length of the diagonal is x. Now, using Pythagoras rule, we have known this angle to be 45, this side to be 1, and this side to also be what? To be 1, since it's a square 1 unit. Now, if I'm now looking for this side x, so that would be x squared, which is the hypotenuse, is equals to 1 square, the opposite, plus 1 square, the two opposite sides. So here I have x squared is equals to 1 square, that is 1, plus 1. So I have x squared is equals to 1 square, that is 1, plus 1. So I can say that x squared here is equals to 1 plus 1, which is equals to 2. So now here, for us to look for our value of x, then take the square root of both sides. So x squared will give you this is side 2 units rather. This is side 2 units and this is side 1 unit. When we look, I told you we are going to take the isosceles triangle, and when we bisected it, this is a square of side 2 units rather. A square of side 2 units. So this is 1 square, which is 1, 2. So here we have root 2. So here should be root 2. So this is an error. This should be square root of 2. Square root of 2, not square root of 3. Now, from the isosceles triangle obtained from above, so you can see, after getting the value here, you can see this is when we bisected the shape to give us 1, 1 and root 2. And this is the angle 45 degrees. So the diagram here is having an error, but the correct diagram is here. So if to take sine 45 degrees now, don't forget sine is opposite all over hypotenuse. If I'm taking this angle, the side facing this angle opposite over hypotenuse, which is over root 2. So that is 1 over root 2, which is still the same thing as root 2 over 2. You can say that it's the same thing as root 2 all over 2, which will still give you the same value when you rationalize in your solve. And if I'm to take cos 45 degrees, that will be adjacent all over hypotenuse. Adjacent, if this is the opposite side, so this will be my adjacent, which is 1 over root 2. You can see that the sine 45 and cos 45 is giving us the same value. Why? Because they are said to be a complementary angle. And tan 45 degrees, that will give us opposite all over adjacent, which is 1 over 1, which will give us 1. So let's just look at 1 or 2 examples under this. This is the only example under this. So here we have find the value of x and y. When you look at this shape very well, we have 2 triangles. This is triangle 1. We have 3. This is triangle 2. And the triangle itself, the whole of the triangle itself is also another triangle. That is, when you remove this line, when you remove that line, you see that you have another triangle. So it means we have 3 triangles here. But only 2 of these 3 triangles are right angles. Why? How? This is one. Is that this triangle is a right angle triangle. And when you remove this line, the whole of the triangle will also give you a right angled triangle, where the right angle triangle is here. So solution now, to get the value of our x and y, let us first look for the value of our x, because we can look for the value of this x, since we are what? We are given the side here. We are given the angle and we are not given the opposite side. So here I can say that the opposite here is x, because this is the angle given to us. So the side facing the angle 60 degrees is x. And I'm also given the hypotenuse side. So when you check your acronym SHOKATUA, which of them talks about opposite and hypotenuse? And that should be sine. So here I have sine 60 degrees to be what? To be opposite all over hypotenuse, which is x over 4 root 3. And when you cross multiply there, you have x is equal to 60 times 4 root 3. Or you can first look for the value of sine 60 degrees, which is root 3 over 2 is equal to x all over 4 root 3. So cross multiply from here, you have x times 2. That will give you 2x is equal to 4 root 3 times root 3. So we have 2x is equal to 4 root 3 times root 3. We give you what? We give you, because root 3 times root 3 will give us root 9. And square root of 9 will give us 3. So you know 3 root 3 will give us 3. Then 3 times 4, that will give us 12. Then divide both sides by 2 to get the value of x. So that will be 6 divided by 2, which is equals to 6 divided by 12 divided by 2, which is equals to 6. So it means the value of our x is what? Is 6. So to get the value of your y now, then you can now take the whole triangle. I cannot use this triangle. This triangle I'm shading, I cannot use it. Why? Because this triangle is not a right angled triangle. So the best thing I can use is to use the whole of the triangle, since I've gotten this side to be what? To be 6 centimeter, or 6 meter rather. So to get my y, use sine 45 degrees. So I'll use this angle because I'm using the whole of the what? Of the triangle. So I cannot use 60 degrees because 60 degrees is not for the whole of the right angled triangle. So to use sine 45, that will be equal to sine opposite all over hypotenuse, which is opposite x over hypotenuse y. So here sine 45 degrees is 1 over root 2, which is equal to, and my x is 6. Don't forget, I've gotten my x to be 6 over what? Over my y, which is the adjacent with the hypotenuse side. So here cross multiply 1 times y will give you y is equal to 6 times root 2 will give me 6 root 2. So here my answer for the value of my y is equal to 6 root 2, where my x is equal to 6. So this is a summary of the basic trigonometric ratios, which you have to know by force. So it is something simple that you can learn. So you can see we have theta. So here is representing theta, which is the angle you are looking for. So we have 30 degrees, 45 degrees, and sorry, this should be 60 degrees, is not 90. That is an error. It should be 60 degrees. So sine 30 degrees will give you 1 over 2. Sine 45, 1 over root 2. Sine 60 degrees, root 3 over 2. Cos 30 degrees, root 3 over 2. Cos 45 degrees, 1 over 2, root 2. Cos 60 degrees, 1 over 2. And tan 30, 1 over root 3. Tan 45 degrees, 1. And tan 60 degrees, root 3. So when you check this table very well, you see that sine 30 degrees is equal to cos 60 degrees. Sine 30, when you check sine 30, 1 over 2. And cos 60 is also 1 over 2. Same thing, sine 45 is also equal to cos 45. Sine 60 degrees is also equal to cos 30 degrees. Why? Because they are said to be a complementary angle. So this comes to the end of our class for today. So please make sure you go through it very well. And I'm giving you your class activities today from your mathematics textbook, which is New General Mathematics for Senior Secondary School 1. So you check the page. The page is there and the question you are going to do. Please, when you want to do this class activity, make sure you draw the diagram and write the instruction before solving your question. And please make your diagram to be very clear. Your workings should also be very clear so that I can be able to see what you write. So make sure you snap it and send it to my WhatsApp. So my WhatsApp number is 081-330-90613. So I wish you best luck. Goodbye.